Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
Welcome to GTC! 25 years after we started working on GeForce, GeForce is sold out all over the world. This is the 5090, the Blackwell generation, and comparing it to the 4090, look how it's 30% smaller in volume. It's 30% better at dissipating energy and incredible performance. Hard to even compare, and the reason for that is because of artificial intelligence. GeForce brought CUDA to the world. CUDA enabled AI, and AI has now come back to revolutionize computer graphics. What you're looking at is real-time computer graphics, 100% path traced. For every pixel that's rendered, artificial intelligence predicts the other 15. AI really came into the world's consciousness about a decade ago. Started with perception AI, computer vision, speech recognition, then generative AI. Generative AI fundamentally changed how computing is done. From a retrieval computing model, we now have a generative computing model. Now, AI understands the context, understands what we're asking, understands the meaning of our request, and generates what it knows. The last couple, 2-3 years, major breakthrough happened. Fundamental advance in artificial intelligence. We call it agentic AI. Agentic AI basically means that you have an AI that has agency. It can perceive and understand the context of the circumstance. It can reason, very importantly, it can reason about how to answer or how to solve a problem, and it can plan an action. At the foundation of agentic AI, of course, something that's very new, reasoning. And then, of course, the next wave is already happening. We're going to talk a lot about that today. Robotics, which has been enabled by physical AI. AI that understands the physical world. It understands things like friction and inertia, cause and effect, object permanence. When some corner doesn't mean it's disappeared from this universe. It's still there, just not seeable. And so that ability to understand the physical world, the three-dimensional world, is what's going to enable a new era of AI we call physical AI, and it's going to enable robotics. The computation requirement, the scaling law of AI is more resilient and, in fact, hyper-accelerated. The amount of computation we need at this point as a result of agentic AI, as a result of reasoning, is easily 100 times more than we thought we needed this time last year. In training, there are two fundamental problems we have to solve. Where does the data come from? Where does the data come from? And how do we not have it be limited by human in the loop? There's only so much data and so much human demonstration we can perform. And so this is the big breakthrough in the last couple of years. Reinforcement learning, verifiable results. So you can kind of see that, in fact, AI is going through an inflection point. It has become more useful because it's smarter, it can reason. It is more used. You can tell it's more used because whenever you go to ChatGPT these days, it seems like you have to wait longer and longer and longer, which is a good thing. It says a lot of people are using it with great effect. And the amount of computation necessary to train those models and to inference those models has grown tremendously. So in just 1 year, and Blackwell has just started shipping, in just 1 year, you could see the incredible growth in AI infrastructure. I've said before that I expect data center build-out to reach $1 trillion, and I am fairly certain we're going to reach that very soon. And the world is going through a platform shift from hand-coded software running on general-purpose computers to machine learning software running on accelerators and GPUs. This way of doing computation is at this point past this tipping point. And we are now seeing the inflection point happening, the inflection happening in the world's data center buildouts. So the first thing is a transition in the way we do computing. Second is an increase in recognition that the future of software requires capital investment. Now, this is a very big idea. Whereas in the past, we wrote the software and we ran it on computers, in the future, the computer is going to generate the tokens for the software. And so the computer has become a generator of tokens, not a retrieval of files. From retrieval-based computing to generative-based computing, from the old way of doing data centers to a new way of building these infrastructure, and I call them AI factories. They're AI factories because it has one job and one job only, generating these incredible tokens. So the world is going through a transition in not just the amount of data centers that will be built, but also how it's built. Well, everything in the data center will be accelerated. Not all of it's AI. This is, in fact, what GTC is all about. You need all kinds of libraries and frameworks. We call them CUDA-X libraries, acceleration frameworks, for each one of these fields of science. But you know, AI started in the cloud. It started in the cloud for good reason, because it turns out that AI needs infrastructure. It's machine learning. If the science says machine learning, then you need a machine to do the science. And so machine learning requires infrastructure, and the cloud data centers had infrastructure. They also have extraordinary computer science, extraordinary research, the perfect circumstance for AI to take off in the cloud and the CSPs. But that's not where AI is limited to. AI will go everywhere. And we're going to talk about AI in a lot of different ways. And the cloud service providers, of course, they like our leading edge technology. They like the fact that we have full stack, because accelerated computing, as you know, as I was explaining earlier, is not about the chip. It's not even just the chip in the library, the programming model. It's the chip, the programming model, and a whole bunch of software that goes on top of it. That entire stack is incredibly complex. There's a whole bunch of companies, maybe 20 of them, who started during the NVIDIA time. And what they do is just one thing. They host GPUs. They call themselves GPU clouds. All right, let's talk about data centers. Blackwell is in full production, and this is what it looks like. It's an incredible, you know, for people, for us, this is a sight of beauty. Would you agree? Blackwell is way, way better than Hopper. And remember, this is not ISO chips. This is ISO power. And in a reasoning model, Blackwell is 40 times the performance of Hopper, straight up. Okay, just to put it in perspective, this is what a 100 megawatt factory looks like. There's a 100 megawatt factory. You have, based on Hoppers, you have 45,000 dies, 1,400 racks, and it produces 300 million tokens per second, okay? And then this is what it looks like with Blackwell. We're now in full production of Blackwell, and now in the second half of this year, we'll easily transition into the upgrade. So we have the Blackwell Ultra NVLink 72. You know, it's 1.5 times more FLOPS. It's got a new instruction for attention. It's 1.5 times more memory. All that memory is useful for things like KV cache. It's 2 times more bandwidth, okay, for networking bandwidth. And so now that we have the same architecture, we'll just kind of gracefully glide into that, and that's called Blackwell Ultra, okay? So that's coming second half of this year. The next click, 1 year out, is named after an astronomer, and her grandkids are here. Her name is Vera Rubin. She discovered dark matter. Vera Rubin is incredible because the CPU is new. It's twice the performance of Grace, and more memory, more bandwidth, and yet just a little tiny 50-watt CPU. It's really quite incredible, okay? And Rubin, brand new GPU, CX9, brand new networking smart NIC, NVLink 6, brand new NVLink, brand new memories, HBM4. Basically, everything is brand new except for the chassis. And so Vera Rubin, NVLink 144, is the second half of next year. And then this now sets the stage for the second half of the year, the following year, we call Rubin Ultra. NVLink 576, extreme scale up. Each rack is 600 kilowatts, 2.5 million parts, okay? And obviously a whole lot of GPUs. And everything is X factored more. So 14 times more flops, 15 exaflops. Instead of one exaflop, as I mentioned earlier, is now 15 exaflops, scaled up exaflops, okay? And it's 4.6 petabytes, so 4,600 terabytes per second scale up bandwidth. I don't mean aggregate, I mean scale up bandwidth. And of course, a brand new NVLink switch and CX9. Okay, so this is what Grace Blackwell looks like, and this is what Rubin looks like. Now that gives you a sense of the pace at which we're moving. This is the amount of scale-up flops. This is scale-up flops. Hopper is 1x, Blackwell is 68x, Rubin is 900x. Okay, so that's very quickly NVIDIA's roadmap. Our InfiniBand switch, the silicon is working fantastically. Second half of this year, we will ship the silicon photonics switch in the second half of this year. In the second half of next year, we'll ship the Spectrum X. Because of the MRM choice, because of the incredible technology risks that over the last 5 years that we did, and filed hundreds of patents, and we've licensed it to our partners so that we can all build them, now we're in a position to put silicon photonics with co-package options, no transceivers, fiber, direct fiber into our switches with a radix of 512. This is the 512 ports. This would just simply not be possible any other way. And so this now set us up to be able to scale up to these multi-100,000 GPUs and multi-million GPUs. Let me talk to you about enterprise computing. This is the computer of the age of AI. Okay, so this is called DGX Station. DGX Spark and DGX Station are going to be available by all of the OEMs. HP, Dell, Lenovo, Asus. It's going to be manufactured for data scientists and researchers all over the world. This is what computers should look like, and this is what computers will run in the future. And we have a whole lineup for enterprise now, from little tiny one to workstation ones, the server ones, to supercomputer ones, and these will be available by all of our partners. We will also revolutionize the rest of the computing stack. Okay, so you can see that we're in the process of revolutionizing the world's enterprise. We're also announcing today this incredible model that everybody can run. And we can make it possible to be enterprise ready for any company, and it's now completely open source. It's part of our system we call NIMS, and you can download it, you can run it anywhere, you can run it on DGX Spark, you can run it on DGX Station, you can run it on any of the servers that the OEMs make, you can run it in the cloud, you can integrate it into any of your agentic AI frameworks. Let's talk about robots. Well, the time has come for robots. Robots have the benefit of being able to interact with the physical world and do things that otherwise digital information cannot. Physical AI and robotics are moving so fast. Everybody pay attention to this space. This could very well likely be the largest industry of all. And so today we're announcing something really, really special. It is a partnership of 3 companies, DeepMind, Disney Research, and NVIDIA, and we call it Newton. Okay, we have another amazing news. Today we're announcing that Groot N1 is open sourced. I want to thank all of you for coming to GTC. We talked about several things. One, Blackwell is in full production. Second, Blackwell NVLink 72 with Dynamo is 40 times the performance, AI factory performance of Hopper. Third, we have an annual rhythm of roadmaps that has been laid out for you so that you could plan your AI infrastructure. And then we have three AI infrastructures we're building. AI infrastructure for the cloud, AI infrastructure for enterprise, and AI infrastructure for robots. Possible. Have a great GTC. Thank you.